Now, when we first defined logarithms, right, we always said that a had to be greater than 1, right? I said that our base couldn't be 0 and it had to be a positive number greater than 1, but I never told you why or talked about why. You just had to assume it. But you shouldn't have to do that. I should tell you. So here's why. Let's pretend I had a base 0. What we have to keep in mind is how logarithms relate to exponents, right? The base of a logarithm becomes the base of an exponent. If I had base 0, then I'd have log base 0 of 2 is equal to some number. I don't know what. But this would imply, if I converted it to an exponent, that 0 to the a equaled 2. Well, this can't be true, right? You can't raise nothing to a power and get something other than 0, right? So I can never have a logarithm with a base of 0. If I had base 1, right, then for example, if I had log base 1 of 2 equals a, well, this would imply, if I converted it to an exponent, that 1 to some power gives me 2. And this can't be true, right? Because 1 to any power is just 1, no matter what that power is. Now let's think about if I had a negative base, right? Let's say I had log of negative 2x equals 1/2. Well, this would imply that negative 2 to the 1/2 is some number, right? Which would give me the square root of negative 2 is x. And that's a complex number. And we can't graph complex numbers. We aren't working with complex numbers, right? We're working in the real world. So because of this, our base can't be 0, 1, or negative 2. And therefore, our base must be greater than 1. So we just showed that logarithms can only have positive bases, right? My base has to be positive of some number, and that's going to give me another number. And I'm going to rewrite this as a positive number. I could rewrite this as an exponent, as a positive number to some power equals x. So first off, let's all agree that a positive number raised to any power is positive. If I have 3 to the negative 2, that gives me 1/9, and I can rewrite that as a logarithm. If I have 3 to the 0, that gives me 1, and I can rewrite that as a logarithm, right? My base is still positive. And if I have 3 squared equals 9, that implies that log base 3 of 9 equals 2. Because a positive number raised to any power is positive, and our bases of logarithms can only be positive, therefore our argument can never be a negative. It has to be positive. So I can't take the logarithm of a negative number. Logarithms of negative numbers are undefined, and I just explained why in the past couple slides, and I'm so glad you asked because we had this one problem in class. This problem in class, where if you solve it, which we're going to do right now, and go through it, the logarithm, it seems like there should be 2 solutions, but I'm going to show you why 27 is the only possible solution. So first thing I want to do is I want to remember that when I am multiplying, when I'm adding logarithms, that's the same as multiplying. So this would give me log base 3 of x squared minus 24x, because I'm multiplying x and x minus 24. That equals 4. So I would get 3 to the 4th power equals x squared minus 24. I would. So 3 to the 4th gives me 81 equals x squared minus 24. I subtract 81 from both sides, and I get that 0 equals x squared minus 24 minus 81. And I say, okay, what are the factors of negative 81 that add up to negative 24? And that's going to be negative 27 and 3, a positive 3. So I'm going to set each of these equal to 0. So I have x minus 27 equals 0, so I get x equals a positive 27. I have x plus 3 equals 0, so x equals a negative 3, right? If I plug in 27, log base 3 of 27 plus log base 3 of 27 minus 24 is 4. Log base 3 of 27 is 3. Log base 3 of 3 is 1, which is 4, right? So that works. But I can't take the logarithm of a negative number. So if I was to take log base 3 of negative 3, that's undefined. So it can't be part of my solution. So our only solution is when x equals 27. These next two examples use change of base. So, friendly reminder that given log base a of m, I could rewrite that as log base b of m over log base b of a. Okay? Now that log base b, right, b could be any positive integer as we have shown, or positive rational number, or irrational too. It just has to be positive. But we could also use natural log, remember, which is log base e, or we could use log, when it's the standard log, it's log base 10. So why don't I go ahead and work through a couple of these examples. So I have 1/3 of log base 2, x plus 6 equals log base 8 of 3x. Now, I know that in order for me to continue solving this problem, I need to get both of these logs to have the same base. Well, I think it'd be easiest to get 8 in some sort of log base 2 form because I know that 8 is 2 cubed. So I'm going to rewrite this right-hand side as log base 2 of 3x, that's my m, my b is 2, over log base 2 of a, which in this case was 8. That gives me 1/3 log base 2 times x plus 6. Well, log base 2 of 8 is 3, right? 2 cubed is 3. So now I can multiply both sides by 3 in order to simplify this logarithm. That's going to give me log base 2 of x plus 6 equals log base 2 of 3x. Note, I can now use the rule. If I have log base a of m equals log base a of n, m equals n. So I can rewrite this as x plus 6 equals 3x. I can go ahead and solve for x. Now I have an equation in a single variable without logarithms. It's a lot easier to solve. So I have 6 equals 2x, so 3 equals x. Let's take a look at this second problem. So I have log base 2 of 2x plus 1 equals log base 9 of 5. I need to get both of these to have the same base, so I can use this theorem right here on the bottom. Well, I've got 3 and 9. Well, I know 9 is 3 squared, so I'm going to go ahead and use the change of base theorem on the right-hand side. So now I have log base 3 of 5 over log base 3 of 9 equals log base 3 of 2x plus 1, which is going to give us log base 3 of 9, which is 2. So I have to multiply both sides by 2. Now I have 2 log base 3 of 2x plus 1 equals log base 2 of 5. Remember that this exponent in front, this constant in front, can be rewritten as an exponent using our logarithm rules. Now I have log base 3 of 2x plus 1 squared equals log base 3 of 5, and I can rewrite this. So I have 2x plus 1 squared equals 5. I'm going to have to go ahead and FOIL this right-hand side. So I've got 4x squared plus 4x plus 1 equals 5. So I get 4x squared plus 4x, subtract 5 from both sides, so I have minus 4 equals 0. And I'm going to pull out a factor of 4. So I have x squared plus x minus 1 equals 0. Now I have to use the quadratic formula in order to determine my what my x values are going to be. They are going to be irrational, right? Because I can't find any factors of -1 that add up to 1, but that is totally okay. You're going to need to use the quadratic formula, and that's going to give you 2 x values. Friendly reminder that you do have to check those x values because you can't take the logarithm of a negative. But I'm going to stop right here because I really just wanted to show you how to use that change of base theorem. I know you know how to solve quadratic functions. We've been doing that most of the semester.